Find the exact value of the integral from 3 to infinity of 2 over x squared dx. Okay, since we have an indefinite integral, we are going to be expressing the integral as the limit as b approaches infinity of the integral from 3 to b 2x to the minus 2 dx. So that is the limit as b approaches infinity. You can actually pull the constant 2 out of the limit and the integral, and then we'll be integrating from 3 to b, or x minus 2. So they'll give us x to the minus 1 divided by minus 1, so it's minus x to the minus 1, and that is evaluated between 3 and b. So that equals twice the limit as b approaches infinity. We can actually take this minus out as well, put that in front of the 2, and then we'll have 1 over x between x equals 3 and x equals b. That's minus 2 times the limit as b approaches infinity of 1 over b minus 1 over 3. That equals minus 2 times. Now, when b approaches infinity, 1 over infinity is 0, and we just have minus a third. So that equals 2/3. The diagram shows parts of the curve with the equation y equals k sine a half x, where k is a positive constant and x is measured in radians. The curve has a minimum point at A. State the coordinates of A. Okay, so y equals k sine a half x. Now, k is the amplitude of this function. The period of the function will be 360 degrees divided by the coefficient of x, which is a half in this case. So the period is 720 degrees. That means one complete loop, which constitutes a crest and a trough, is going to be a single period. So if you like, it's a wavelength. So that's 720 degrees. This point here will be 360 degrees. That means that point A will be 540 degrees, and this point up here, the top of the crest, will be at x equals 180 degrees. Now, the value, turning point, the minimum point at A, is 540 degrees. Let's call it y1 for now. So when x is 540 degrees, we have y equals k sine a half 540, which is k sine 270, and sine 270 is minus 1, so y will be minus k. So coordinates of A will be 540 degrees minus k. Now x is measured in radians, so it's not 540 degrees. The equivalent of 540 degrees will be 3 pi. So A will be the point 3 pi minus k. The sequence of transformations is applied to the curve in the following order. First, a translation of 2 units in the negative y direction, and then a reflection in the x-axis. Find the equation of the new curve and determine the coordinates of the point on the new curve corresponding to point A. Okay, so we're going to start by calling the function f of x, just that we can refer to the transformed functions as g of x and h of x. The first transformation is a translation of 2 units in the negative y direction. That means that we are taking the function f of x and shifting it 2 units down. So the value of q in this case is 0. So we are shifting f of x down 2 units. So g of x, which is a transformed shape by the translation, will be f of x minus 2. So that will be k sine a half x minus 2. And then the next transformation is a reflection about the x-axis. So when we reflect a function about the x-axis, we change the sign of y. In other words, our transformed shape, the reflection about the x-axis, h of x, we change the sign of y, so we change the sign of g of x. So h of x will be minus g of x. So that will be minus k sine a half x minus 2, and that equals minus k sine a half x plus 2. This is the function h of x. Now the corresponding point, the point corresponding to a, if we just take g of x first, because the first transformation was the translation 2 units down. So a prime, we're going to call it a prime. What gets affected here is the value of y. So the x coordinate is still 3 pi, and the y coordinate shifts every point on f of x will shift 2 units down. So the y coordinate will be minus k minus 2, and then a double prime, which is going to be the reflection of g of x about the x-axis. We change the sign of y. So the coordinates of a double prime, the x coordinate will be 3 pi, and we change the sign of the y coordinate. So we will have minus k minus 2. So a double prime will therefore be 3 pi k plus 2. The curve is such that dy dx equals 3 times 4x plus 5 to the half. It's given that the points 1, 9, and 5a lie on the curve. We're required to find the value of a. Okay, so we are given the derivative function of a curve, and we are given 2 points that lie on the curve. So we are going to need to find the equation of the curve first and foremost before we can use these points 1, 9, and 5a. So to find the equation of the curve, we're going to take the derivative function and integrate with respect to x. So the integral of dy dx equals the integral of 3 times 4x plus 5 to the half dx. So the integral of dy dx will just give us y. 3 is a constant term. We'll take that out of the integration. We are now going to be integrating 4x plus 5 to the half. So we're going to add 1 to a half to give us 3 over 2. We divide by this exponent, 3 over 2. And we also divide by the derivative of the content of the bracket with respect to x. So the derivative of 4x, which will be 4. So we'll be multiplying by 1 over 4, and we add the constant of integration. So y will be 3 divided by 3 over 2 is the same as 3 times 2 over 3. So that'll just give us 2. And then 2 times a quarter will give us a half. So we have y equals a half times 4x plus 5 to the 3 over 2 plus c. Now this is the equation of the curve. To find the constant of integration, we're going to substitute this point 1, 9 in. Substituting this point in isn't going to help because we are A, trying to find the value of A, and B, it's an unknown variable. You're going to introduce another unknown variable inside this equation, which means you'll have 2 unknown variables. So we're substituting 1, 9 in the equation of the curve. So 9 equals a half times 4 times 1 is 4 plus 5 is 9. 9 is 3 squared, and that's to the power of 3 over 2 plus c. 9 equals a half. 3 squared to the 3 over 2 is 3 cubed, which is 27 plus c. 18 equals 27 plus 2c. 2c equals minus 9. c equals minus 9 over 2. So the equation of the curve is y equals a half 4x plus 5 to the 3 over 2 minus 9 over 2. We now substitute the second point in because you're trying to find the value of a. So a equals a half times 5 substituted We substitute 5 in for x, so 4 times 5 is 20 plus 5. 25 is 5 squared to the 3 over 2 minus 9 over 2. A equals a half times 5 squared to 3 over 2 is 5 cubed, which is 125 minus 9 over 2. A is 125 minus 9 over 2, which is 116 over 2. A therefore equals 58. Question 4. Prove that sine theta plus cos theta all squared minus 1 over cos squared theta equals 2 tan theta. Okay, with all trigonometric identities, the general rule of thumb is to work with the side of the equation that is more complex. So in this case, that will be the left-hand side. Look, in some cases, you will need to manipulate both sides of the equation, but in most cases, you only need to manipulate one side, and that's the more complex side. So the left-hand side, we're going to square out these brackets here. So we'll have sine squared theta plus 2 sine theta cos theta plus cos squared theta over cos squared theta. Sine squared theta plus cos squared theta equals 1. That is your square identity. So we'll have 1 plus 2 sine theta cos theta over cos squared theta. Sorry, we forgot a minus 1 as well in the numerator. So now we have 1 minus 1 is 0. We have 2 sine theta cos theta over cos squared theta. Cos will cancel with cos, so we have 2 sine theta divided by cos theta. Sine theta over cos theta is your your quotient identity rather. So that equals 2 tan theta, and that equals the right hand side. Hence solve the equation sine theta plus cos theta all squared minus 1 over cos squared theta equals 5 tan cubed theta for theta between minus 90 and 90 degrees. Now the whole purpose of the first question was to show and express this expression here as a single trig ratio, which was 2 tan theta. And the only way we can solve a trigonometric equation is if you have a single trigonometric ratio. So 2 tan theta equals 5 tan cubed theta. We're now going to take all the terms over to the one side of the equation. The other side equals 0. Take out a common tan theta. Tan theta times 5 tan squared theta minus 2 equals 0. Tan theta equals 0, or tan squared theta equals 2 over 5. Tan theta therefore equals plus or minus the square root of 2 over 5. So for tan theta equal to 0, theta will be 0 degrees or 180 degrees or 360 degrees. Now the interval is minus 90 to 90. So if you just draw a cos diagram, we're working in the first quadrant, which is your positive acute angle, and then in the fourth quadrant put the negative acute angle. So you're working in these two quadrants here between minus 90 and 90. So the only valid solution is theta equals 0 for this trigonometric equation, and then the reference angle for tan theta equals plus or minus root 2 over 5. So the reference angle is theta equals 32.3 degrees. Now we're working in the first and fourth quadrant, the positive and negative acute angle. So 32.3 will fall in the first quadrant here. So this is one solution, 32.3. And the negative acute angle, because we're looking at this at the plus minus solution here. So we need to, from these two quadrants, the only quadrant that tan theta is positive in will be the first quadrant. So that will be this solution, theta is 32.3. And the negative solution will be in the fourth quadrant where tan theta is negative. So or theta is minus 32.3 degrees. So these are your solutions for theta. The curve has the equation y equals 3 over 2x squared minus 5. Find the equation of the normal to the curve at the point 2, 1, giving an answer in the form ax plus by plus c equals 0, where a, b, and c are integers. Okay, so we're given a curve, y equals 3 over 2x squared minus 5. Okay, to find the equation of the normal. A normal is a straight line that is perpendicular to a tangent. To find the equation of a normal, we're first going to need to know what the gradient of the normal is. We know the point of contact of the normal in the curve, which is 2, 1. We need to find the gradient of the normal, and we're going to find the gradient of the normal by finding the gradient of the tangent to the curve at this particular point, 2, 1. So to find the gradient of a tangent, we are going to find dy dx. We're going to differentiate this function. But before we do that, we must put it into differentiable ready form. So y equals 3 times 2x squared minus 5 to the minus 1. We can now find dy dx, which will be minus 3 times 2x squared minus 5 to the minus 2 times 4x. Using the chain rule, we've got to find the derivative of 2x squared minus 5. Just cleaning that up, we have minus 12x divided by 2x squared minus 5 all squared. This now represents the gradient of a tangent to the curve. To find the gradient of the tangent to the curve at this particular point, we're going to evaluate dy dx where x equals 2. So dy dx where x equals 2 equals minus 12 times 2 over 2 times 2 squared minus 5, and that is all squared. Gives us minus 24 over 2 cubed is 8 minus 5 is 3, 3 squared is 9. Minus 24 over 9 is simplified, minus 8 over 3. So this is the gradient of the tangent to the curve at the point 2, 1. Therefore, the gradient of the normal to the curve at this point will be the reciprocal of the gradient of the tangent with opposite signs. The gradient of the normal will be 3 over 8. We have the point of contact, which is 2, 1, so we can now determine the equation of the normal. Y minus y1 equals m times x minus x1. You can also use y equals mx plus c if you prefer. You'll get the same equation regardless of which method you choose to use. So y minus 1 equals 3 over 8 times x minus 2. Y equals 3 over 8x minus 3 quarters plus 1. Y equals 3 over 8x plus a quarter. You can leave it in this form. You can also write it in a neater form. Well, they want it in this form, ax plus by plus c. So 8y equals 3x plus 2, but they want it in that form, ax plus by plus c. So 3x minus 8y plus 2 equals 0, and this is the form that they wanted in. Question 6, it's given that the coefficient of x cubed in the expansion of 2 plus ax to the power of 4 times 5 minus ax is 432. We're required to find the value of the constant a. Okay, we only require the coefficient of x cubed out of this expansion. So we're not going to expand the first binomial completely, because when we multiply the terms of this first bracket by the second bracket, 5 minus ax, we need to get terms in x cubed. So any term that is not going to give us a term in x cubed, so in other words, a power of x that'll give us higher powers than x cubed, we're not interested in. So we are just going to expand this as much as necessary. So this will give us 4 choose 0, 2 to the 4, plus 4 choose 1, 2 cubed times ax, plus 4 choose 2, 2 squared times ax squared, plus 4 choose 3, 2 to the 1 times ax cubed, and finally 4 choose 4 times ax to the 4. Now, if we look at all the terms, all 5 terms of this expansion, when we multiply every single one of those terms by this bracket 5 minus ax, we need to get terms in x cubed. That's all we're interested in. The first term doesn't contain a term in x, so multiplying by 5 minus ax is not going to give us a term in x cubed, so we can disregard that term. We take the second term, we've got a term in x. When we multiply by 5 minus ax, we are only going to get a term in x squared, so that's not going to help us either. When we take the third term, we have an x squared already. We're going to multiply by an x, so this will give us a term in x cubed, so we are interested in that. When we take the fourth term, which has a term in x cubed, when we multiply by 5 minus ax, we will get a term in x to the 4, but we're also going to get a term in x cubed because we're going to multiply 5, the constant, by this term in x cubed. So we are interested in this term. And the last term has a term in x to the 4. Multiplying it by 5 minus ax is just going to give us a term in x to the 5 and still a term in x to the 4. So we're not interested in that last term. So the only thing we're interested in are the third and the fourth term of this expansion. So the coefficient of x cubed, we're going to look at 4 choose 2. 2 squared is 4. And then we have a squared x squared plus 4 choose 3 times 2a cubed x cubed. Now we're going to take these terms here and we're going to multiply by 5 minus ax. And when we multiply the first term, the first set of brackets with the first term of the second set of brackets, we are going to still get a term in x squared. We won't get a term in x cubed, so we're not interested in that. The first term of the first set of brackets times the second term of the second set of brackets will give us a term in x cubed. We have an x squared term here and an x term there, so we are interested in that term. So 4 choose 2 times 4a squared x squared times minus ax plus the last term, the inners, will give us a term in x cubed, so we are interested in that. 4 choose 3, then 5 times 2 is 10a cubed x cubed, and then the last two terms will give us a term in x to the 4. We're not interested in that. So these are the only terms that we're interested in. 4 choose 2 is going to be 4 times 3 over 2. 12 over 2 is 6. 6 times 4 is 24. And we have a minus, so it's minus 24 a cubed x cubed plus 4 choose 3 is 4 times 3 times 2. 24 divided by 3 times 2 times 1. 24 divided by 6 is 4. 4 times 10 is 40. 40 a cubed x cubed. So the coefficient of x cubed in this expression is minus 24a cubed plus 40a cubed, which is 16a cubed. And we're told that the coefficient of x cubed in this expansion is 432. So 16a cubed equals 432. That means that a cubed equals 432 divided by 16, 27, and the cube root of 27 is 3. So a equals 3. The straight line y equals x plus 5 meets the curve 2x squared plus 3y squared equals k at a single point P. Find the value of the constant k. Okay, the fact that the straight line meets the curve at a single point, they're essentially telling us that y equals x plus 5 is a tangent to this curve. So the fact that the straight line meets the curve means that there's a point of intersection. So 2x squared plus 3 times x plus 5 all squared equals k. 2x squared plus 3 times x squared plus 10x plus 25 equals k. And now we're going to find the discriminant here because the straight line is a tangent to the curve. It means there's one point of intersection. For one point of intersection, the discriminant delta must equal 0. So delta equals b squared minus 4ac, which is 30 squared minus 4 times 5 times 75 minus k. So delta equals 900 minus 1500 plus 20k. And for equal roots, delta equals 0. So 20k minus 600 equals 0. 20k equals 600. K equals 30. Next, we're required to find the coordinates of P, which is the point of intersection of the tangent to the curve. Now, we have the quadratic 5x squared plus 30x plus 75 minus k equals 0. That was the resulting expression we got when we equated the tangent to the curve. So, since we've just established that k is 30, 5x squared plus 30x plus 75 minus 30 equals 45 equals 0. Dividing through by 5 gives us x squared plus 6x plus 9 equals 0. And that will factorize as x plus 3 times x plus 3. So x equals minus 3. And it shouldn't be surprising that we have one x value, because the line is a tangent to the curve and there's clearly only one point of intersection. Now, to find the y-coordinate of the point of intersection, the point of contact between the tangent and the curve, we're going to substitute this back into the straight line. Y equals x plus 5. So y equals minus 3 plus 5, which is 2. So the point of contact, P, will be the point minus 3, 2. Question 8. An arithmetic progression is such that its first term is 6 and the 10th term is 19.5. We're required to find the sum of the first 100 terms of the arithmetic progression. Okay, so a equals 6 and the 10th term is 19.5, which is 39 over 2. A plus 9d therefore equals 39 over 2. A is 6, so 6 plus 9d equals 39 over 2. 9d equals, so that's going to be 27 over 2, and then d will be 27 over 2 divided by 9, which is 27 over 18. Dividing through by 9 will give us 3 over 2. So d equals 3 over 2. We're required to find the sum of the first 100 terms. So n equals 100. The sum to n terms is n over 2 times 2a plus d times n minus 1. The sum to 100 terms is therefore 100 over 2 times 2a, 2 times 6 is 12, plus d, which is 3 over 2 times n minus 100 minus 1 is 99. And then the sum to 100 terms is therefore 8025. A geometric progression a1, a2, a3 such that a1 is 24 and the common ratio is a half. The sum to infinity of this geometric progression is denoted by s. The sum to infinity of the even numbered terms, in other words term 2, term 4, term 6, etc., is denoted by s sub e. Find the values of s and s sub e. Okay, so we have a geometric progression a1, a2, a3. a1 is 24, so 24, a2, a3 is our geometric sequence, and the common ratio is a half. So 24 is the first term, the second term will therefore be 12, and half of 12 will be 6. So these are the first three terms of the geometric progression. The sum to infinity is denoted by s, so we're just going to start by sum to infinity is a over 1 minus r. So that'll be 24 over 1 minus a half, 24 over a half, so the sum to infinity will be 48. Now the sum to infinity of the even numbered terms is denoted by SE, S sub E. So the sum to infinity again is a over 1 minus r, but our sequence now are the even numbered terms. So We're going to start with term 2, which is 12. We halved at 6, we halve it again. This term is 3, so the next term will be 3. We halve 3, 3 over 2, and halve it again, 3 over 4. So the next term of the even number terms will be 3 quarters. So this is our sequence now. A is 12, and R is now a quarter. So it'll be 12 over 1 minus a quarter is 12 over 3 quarters, 48 over 3 is 16. So the sum to infinity of the even number terms is 16. Functions f and g are defined for all real values of x by f of x equals 3x minus 2 all squared plus k, and g of x equals 5x minus 1, where k is a constant. Given the range of the function g of f greater than g of f of x is greater than or equal to 39, find the value of k. Okay, so the function g of f will be g of 3x minus 2 all squared plus k, which will be 5 times 3x minus 2 all squared plus k minus 1. Now, the range of this function is of x is greater than or equal to 39. We need to first bring this 5 into the square brackets because k is a constant here. So 5 times 3x minus 2 all squared plus 5k minus 1. The 5k minus 1 represents the y-coordinate or the turning point of this function g of f. And the fact that the range is greater than or equal to 39, that means that 5k minus 1 is greater than or equal to 39. 5k is greater than or equal to 40, so k is greater than or equal to 8. So therefore, k must be 8, since this is the value of k that will yield the range that we are given. So the value of k will be 8. For this value of k, determine the range of the function f of g. So f of g of x will be f of 5x minus 1. So that will be 3 times 5x minus 1 minus 2 all squared plus 8. So that'll be 15x minus 3 minus 2 all squared plus 8. So that's 15x minus 5 all squared plus 8. Now the range of this function will be indicated by the constant. So the range will be f of g is greater than or equal to 8. The function h is defined for all real values of x and is such that g of h of x equals 35x plus 19. We're required to find an expression for the inverse of g, and hence otherwise find an expression for h of x. Okay, so g of x is 5x minus 1, and we are told that g of h of x equals 35x plus 19. G we switch the x and y around, so x equals 5y minus 1, 5y equals x plus 1, so y will be x plus 1 over 5, or a fifth x plus 1. This is now the inverse of g. Now we need to find an expression for h of x, given that g of h of x is 35x plus 19. So g of h of x will be replacing x with h of x. We'll have 5 h of x minus 1, and that equals 35x plus 19. So 5h of x equals 35x plus 20. We can divide through by 5 now, so h of x will be 7x plus 4. We can also find an expression h of x by using the inverse of g. Given that g of h of x is 35x plus 19, h of x equals g to the minus 1, okay, 35x plus 10. We've just established an expression for g to the minus 1 plus x plus 1. Okay? So we're replacing x with 35x plus 19. So we have 35x plus 19 plus 1 divided by 5. That's 35x plus 20 over 5. H of x equals 7 as a plus. So I arrive at the same answer, just using a different approach by using the inverse of g. Question 10. The diagram shows the circle with center c minus 4, 5 and radius root 20 units. The circle intersects the y-axis at the points A and B, and the size of angle ACB is theta radians. We're required to find the equation of the tangent to the circle at the point minus 6, 9. Okay, so firstly, a tangent is a straight line. And to find the equation of a straight line, we need to know the gradient of that line and one point that lies on the line. Okay, so we are actually given the point minus 6, 9. So all we need to do now is find the gradient of the tangent, and we can find the equation of the tangent. So to find the gradient of the tangent, we are first going to need to establish the equation of the circle. So the center is minus 4, 5, and the radius is root 20 units. So the equation of the circle is x plus 4 all squared plus y minus 5 all squared equals 20. Now the circle cuts the y-axis at the points A and B. So because they're y-intercepts, the x-coordinates of A and B will both be 0. So to find y-intercept, we put x equal to 0. 0 plus 4 squared will be 16 plus y minus 5 all squared equals 20. Y minus 5 all squared is 20 minus 16, which is 4. Y minus 5 square root in both sides, therefore equals plus or minus 2. So y equals plus or minus 2 plus 5. Y equals 2 plus 5, 7. Or y equals minus 2 plus 5, which is 3. So the coordinates of A are 0, 7, and the coordinates of B are 0, 3. Now, because we have a circle and we are dealing with tangents, we know that the radius of a circle is perpendicular to a tangent at the point of contact. So if we just estimate where the point minus 6, 9 is, let's for argument's sake say it's over there. We draw a tangent at that point, we'll call that point C. So we can't call it C, let's call it D. And we just join D to C, forming a radius. Now that angle between the radius and the tangent at D is 90 degrees. So we know the coordinates of D, because that is the point of contact, minus 6, 9, and the coordinates of C is minus 4, 5. So we can determine the gradient of DC, which is y2 minus y1 over x2 minus x1. That'll be 5 minus 9 over minus 4 plus 6. So that's minus 4 over 2, which is minus 2. Therefore, the gradient of the tangent at the point D minus 6, 9 will be a half, the reciprocal of 2 with opposite sign. And we have the point of contact minus 6, 9, so we can determine the equation of the tangent at D, y minus y1 equals m times x minus x. Well, you can also use y equals mx plus c. You'll get the same answer. It's just a lot quicker to use y minus y1 equals m times x minus x1 to get the equation of the tangent. So y minus 9 equals a half times x plus 6. Y equals a half x plus 3 plus 9. So y equals a half x plus 12. And this is the equation of the tangent at the point D minus 6, 9. This is not in the form that they require the equation of the circle. It's got to be in this form over here. So multiplying this all out, x squared plus 8x plus 16 plus y squared minus 10y plus 25 equals 20. X squared plus y squared plus 8x minus 10y. That will be 16 plus 25 is 41, minus 20 is 21, so plus 21 equals 0. Now, next we're required to find the value of theta. Now we know, just looking at sector ACB, you'll probably automatically be thinking to find theta you can use arc length equals r times theta, but that would mean that you would first need to determine the length of arc AB. We know the coordinates of A and of B, which are 0, 7 and 0, 3 respectively. We know that AC and BC are both root 20 units in length because they are the radii of the circle. We can therefore determine the length of AB. We know that AB is therefore 4 units. So we can use the cos rule to find theta. So AB squared, which is 4 squared, equals root 20 squared plus root 20 squared minus 2 times root 20 times root 20 cos theta. So 16 equals root 20 squared is 20, 20 plus 20 is 40, minus root 20 times root 20 is 20 times 2 is 40. So 16 equals 40 minus 40 cos theta. 40 cos theta equals 24. So cos theta is 24 over 40. It's going to be 3 over 5. So theta will be, in radians, shift cos 3 over 5. Theta is 0.9273 radians. Next, we're required to find the perimeter and the area of the segment shaded in the diagram. So starting with the perimeter of the shaded segment will be arc length AB plus the length of line segment AB. So the arc length of AB, remember that arc length equals radius times the arc angle. So the radius is root 20. So the arc length will be root 20 times the arc angle theta, which is 0.9273, plus the length of AB, which we know is 4 units. So the perimeter of the shaded region equals 8.147, so 8.15 units. Now the area of the shaded region will be the area of sector ACB less the area of triangle ACB. So that will equal, the area of the sector is a half the radius squared times the arc angle. So the radius is root 20, so root 20 squared times the arc angle 0.9273 minus the area of triangle ACB, which is going to be a half AC times CB sine theta. So it will be half root 20 sine theta. So the area of the shaded region equals 1.273 units squared. Question 11. The diagram shows a curve with the equation y equals 2x to the minus 2/3 minus 3x to the minus third plus 1 for x is greater than 0. The curve crosses the x-axis at the points A and B and has a minimum point M. We're required to find the exact coordinates of point M. So M being a stationary point means that we are going to be first finding an expression for dy dx and equating that to 0 because dy dx equals 0 for stationary points. So y equals 2x to the minus 2/3 minus 3x to the minus a third plus 1. So dy dx will be 2 times minus 2/3 minus 4/3 x minus 2/3 minus 1 is minus 5/3 minus 3 times minus a third is plus 1 x to the minus a third minus 1, so x to the minus 4/3 and the derivative of 1 is going to be 0. And then we equate dy dx to 0 for stationary points. So x to the minus 4/3 equals 4/3 x to the minus 5/3. Then we divide through by x to the minus 5/3, which means we'll have x to the third equals 4/3, and then we're going to raise both sides to the power of 3, so x will be 4 cubed, 64 over 3 cubed, 27. So x is 64 over 27, and we need to now find the y coordinate of m, so we can substitute this x value into the function. So f of 64 over 27 equals, so m is the point, 64 over 27 minus 1 over 8. Finally, we're required to find the area of the region bounded by the curve and the line segment AB. So we are looking for this area, the area of this region. A and B are the x-intercepts of the curve. So to find the x-intercepts, we put y equal to 0. So 2x to the minus 2/3 minus 3x to the minus a third plus 1 is 0. We're just going to use the substitution so we can factorize an easier quadratic. So we'll just let p equal x to the minus a third, which means that p squared is x to the minus 2/3. So we have 2p squared minus 3p plus 1 equals 0. That factorizes as 2p minus 1 times p minus 1. P equals a half, or p equals 1. Therefore, x to the minus a third equals a half, or x to the minus a third equals 1. We raise both sides to the minus 3. So x equals 1 over 2 to the minus 3, which will be 8. So B will be the point 8, 0. And we likewise do the same with the other equation. So x will be 1. A is therefore the point 1, 0. Now the area of the shaded region will be the integral from x equals 1 to x equals 8. So your boundaries of integration will be from A to B. And the difference between the curves, so the x-axis is your first curve, and the second curve is the function that we're dealing with. So we will have the y values, y equals 0 less the y values for the function, which is this expression over here. So it'll be 0 minus 2x to the minus 2/3 minus 3x to the minus third plus 1, and we integrate this with respect to x. That equals, minus 2 is a constant. The integral of x to the minus 2/3, we're going to add 1 to minus 2/3, so it'll be x to the third, and we divide by a third. plus 3 is a constant. X to the minus a third, so we add 1. So we're going to get 2/3, and we divide by 2/3. And then the integral of minus 1 is going to be minus x, and this is all evaluated between x equals 1 and x equals 8. So that equals minus 2 divided by a third is minus 2 times 3, so minus 6 x to the third. 3 divided by 2/3 is 3 times 3 over 2, so that's 9 over 2 x to the 2/3 minus x, all evaluated between x equals 1 and x equals 8. So that equals minus 6 times 8 to the third, so that's 2 cubed to the third, plus 9 over 2 times 2 cubed to the 2/3, minus 8, minus, when x equals 1, minus 6 times 1, that'll be minus 6 plus 9 over 2 minus 1. So the area equals minus 12 plus, it's going to be 2 squared 4 times 9, 36 divided by 2 is 18, minus 8, and then plus 6 minus 9 over 2 plus 1, and that equals half a unit, or 0.5 units squared.